Okay, g'day all and welcome to another video. So today what I wanted to do is answer an interesting question. Are CPUs still getting faster? And the short answer to that is yes. But the long answer is as follows. We're actually assembly programmers here on this channel, so what I decided to do is write my own benchmark. But the code for this benchmark is up on GitHub, and I'll leave a link down below so that you can get the code or the binaries. So the benchmark is all based around the Phenom 2. So what we're going to be doing today is testing my laptop's CPU, which is an i7 8750H, I think. It's a mobile CPU, but we're going to test this laptop CPU from 2018 against my old Phenom 2, which is from 2009, and we're going to see what happens. Yeah, so the benchmark is called How Many Phenom 2s is my CPU? And what I've done is timed a benchmark on my Phenom 2, which is down there in the corner. Okay, so the exact Phenom 2 that we're actually testing against here, the Phenom 2 810, it's a quad core. So back in the day, there was actually 6 core Phenom 2s, but the one that I had was a quad core. It was released in 2009. Its frequency is 2.6 gigahertz. It's got 4 cores and 4 threads. The TDP is 95 watts. The price was $175 US. So that's actually really cheap. So the caches of this Phenom 2 are really, I think, amazing for the day and pretty good for nowadays as well. So there's 4 times 64K L1 caches. The L1 cache on these old Phenom 2s it's astonishing. Decent sized L2 as well. We got 502K per core, 16-way set associative. The L3 cache, which is shared, that's 4 megabytes. The CPU has MMX 3D now. We've also got SSE 1, 2, and 3. I think the extensions to SSE 3 as well. I think. I'm not sure. Yeah, but that's the stats of the Phenom 2 that we're racing against here. So the K10 Phenom 2 810 quad core. This is the computer that I raced against the Phenom 2. It's an i7 8750H, so it's a mobile chip. Its frequency is 2.2 gigahertz up to 4.1 gigahertz. So this CPU will actually increase the frequency if it's only using, say, 1 or 2 cores. It has 6 cores and 12 threads. So that means that it's got hyper-threading. Okay, the TDP is 45 watts, which is fair enough, really. It's a mobile processor. Okay, so the caches, you can already see when you have a bit of a look at these caches here compared to the Phenom 2, these L1 is only 32K. So the Phenom 2 had twice the L1 per core. And the latency there, the access latency is, the fastest latency there is 4 cycles compared to 3 of the Phenom 2. This chip also has L2, 256K of L2, 4-way set associative, and it's got 9 megs of shared L3. I would like to expand the benchmark if there's interest into testing the L1, L2, and L3 cache speeds. Especially like to test the Ryzen L3 cache. That sounds very interesting. They have a marvelous L3 cache. This CPU does MMX, SSE 1, 2, 3, 4, AVX, and AVX2. That's good. So let's have a bit of a look at the benchmarks themselves. Okay, so my focus wasn't great. I hope you can make that out. So the one on the left-hand side of the screen is the Phenom 2 itself. And the one on the right-hand side of the screen is my Windows CPU. So I do want to point out that the operating systems are different. The Phenom is running on Ubuntu or Linux, and the i7 is running on Windows. But we're testing hardware instructions, so this is just assembly. Anyway, let's go through this little benchmark here. So we've got 6 tests. Add, bool, shift, padd, which is MMX, CMOV, and the flops, or floating point operations per second. First, we'll run through all of the single core versions, or the scalar versions, and after that, we'll run through the same tests with all of the cores pumping through the instructions and see what we can do. Okay. Just set it up on both computers and hit enter at the same time, and they're off and running. Who will win? So all this is doing is performing add to registers and 1, so it's just incrementing registers, but it's doing it 100 billion times, yeah, for each run. Yeah, and we do 10 runs. Okay, so you can see down there that the i7 8750 is taking about 6.9 seconds to do 100 billion additions, and the Phenom there on the left hand side is taking about 14 1/4 seconds to do 100 billion. Yeah, so the i7 in this instance will actually be clocking its frequency all the way up to approximately 4.1 gigahertz. I think it is a bit shy of that, but it can detect that it doesn't have all of its cores running. The i7 is finished, and we can see here that it says it executed 15.51 billion instructions per second in that particular test, and it says that its score is 2.057 Phenom 2's worths, which means that it's a little bit more than twice as fast as the Phenom 2. Okay, and at that point the Phenom 2 finishes as well. So I just fast forwarded a bit there because it's quite boring to watch. But the Phenom 2 executed 7.54 billion instructions per second. Let's move on to the next test. The next test is AND, or Boolean instructions. And they're off and racing again. Yeah, so once again, you can see that the i7 is approximately twice as fast. Maybe that's what you'd expect. I mean, this Phenom 2 is from 2009, the i7 is from 2018, so there's 9 years of difference here. 9 years of difference. Okay, so our i7 is finished. It did about 15.5 billion instructions per second, and that represents a score of 2.027 Phenom 2's worths. And eventually the Phenom finishes as well. It scores 7.6 or 7.7 billion instructions per second. Okay, so the i7, clear winner so far. Let's move on to the next test. Now this next test, shift right, is another assembly instruction. This is one that shifts a register right, shifts the bits of it right by the value in another register, which is CL. And we start to see something a little bit interesting here. Yeah, you can see that over there. The Phenom has actually finished one iteration in about 14 seconds. The i7 hasn't even done one. The Phenom's finished 2 iterations. Okay, so at this point, the Phenom has finished 4 iterations of 100 billion of these shift reg and CLs. The i7 has only done 1. So the i7 takes almost a minute to do this. Although the Phenom 2 was thrashed with both the add instruction and the Boolean instruction, and the Phenom 2 is absolutely annihilating this modern hardware with this shift instruction. All right, let's fast forward a bit. This is going to take a long time. Okay, at that point we're finished with the Phenom 2. Anyway, the Intel chip has about 100 years to go, but the Phenom 2 says that it performed 7.54 billion shifts per second, which is equivalent to 1 Phenom 2's worth. Fair enough. And the i7 will keep going for 100 million years, as we can see there. So we'll just fast forward to the end. Okay, so at that point, the i7 finishes the shift instruction. So the i7 executed roughly 2 billion instructions per second, and that's equivalent to 0.26 Phenom 2's worths. So Intel is actually I believe fairly consistent with the slowness that they code this shift reg and CL instruction. If anybody has a modern 9900 or a Ryzen chip, I would love to see the performance of this instruction, shift reg and CL. Okay, so we're moving on to our next test. This is P-add-B. Now this is add packed bytes as a SIMD instruction. Is part of the MMX instruction set. So that was the first SIMD instruction set, added way back when, like the Pentium 3 or something days. And Intel actually makes modern CPUs run these MMX instructions slowly. And they're doing that to encourage programmers not to use MMX. And you can see here, sure enough, the Phenom is much, much faster at MMX than the Intel chip. Yeah, but interesting stuff. So the Phenom 2 just there executed 20.73 billion byte additions per second. It's a lot. That's a lot. Yeah, it's equivalent to 1 Phenom 2's worth. Let's fast forward. Okay, so the Intel chip just there ended up performing 7.831 billion instructions per second, or byte additions per second, which is equivalent to just a little over 1/3 the speed of the Phenom 2, which makes sense, really. Yeah, this is something that Intel is open about. Don't use MMX instructions. Okay, test number 5, CMOV, or the conditional move. Now, these are really important in branchless programming. The Phenom is slightly slower at performing 100 billion CMOVs, but not a lot. Yeah, that's actually pretty close. So we're talking 14.2 seconds versus 14 seconds, pretty much. Very, very close. Okay, and there we finished the CMOV. So you can see that the Phenom and the Intel chip, yeah, much of a muchness really. So for CMOVs or conditional moves for branchless programming, the old Phenom is, it's plenty able to keep up with modern hardware, at least in the scalar version, in the single-threaded version. Let's move on to the final test, flops. Let's test some flops. So this is floating point operations per second, and this is really where the speed of modern hardware shines. Yeah, so the modern hardware in this instance can use AVX, whereas the old Phenom didn't have AVX. So it's got to do all of these floating point operations with SSE. Okay, so the Intel chip is finished. It just performed 51.3 billion instructions per second. Okay, and there we are. We're all done. So the Phenom executed 10.37 flops or floating point operations per second, or 10.37 billion floating point operations per second, which is, it's not too bad. It's slow compared to the 8750 over here, which executed 51.3 billion. The 8750 is 5 times faster at floating point operations than the Phenom. Modern i7, or the 2018 i7, was good at add, it was good at AND, it was terrible at shifting, it was terrible at MMX, it was average at CMOVs, and it's really good at flops. So we can see already, just in the scalar performance, that things are not quite so clear as saying something so simple as modern hardware is obviously faster than old hardware. So what we might do now is move on to something even more interesting, I think, which is multi-threading. Let's turn all of these cores on, all of these hyperthreads on, and repeat and see what happens. Okay, so you hit 7 in the little program there to turn on the threads, and what you can see down the bottom there, it says 7, toggle multi versus single threads, current equals 4, which means that the Phenom is going to turn on all 4 of its cores. And over here on the Intel, on the right-hand side, you can see toggle multi-thread, current equals 12. So the Intel chip is going to be using all of its cores and all of its hyperthreads as well. So that's 2 threads per core. And as I was saying before, we're not reading or writing to memory here, so pretty much all of the resources that the hyperthreads would normally share and have to fight over, we're not using those things. So this is almost the best scenario for hyperthreading. Let's move on. Let's move on to the first test, add. Once again, we're doing 100 billion operations per test. We're just divvying them out to all of the cores and timing that. Okay, so you can see here the Phenom is running at about 3.57 seconds to do 100 billion operations. The Intel has finished. Yeah, so the Intel chip just ended up doing 89.03 billion instructions per second, and it's almost 3 times as fast as the Phenom 2. So the Phenom 2 ended up doing 30.1 billion operations per second, which is equivalent to 1 Phenom 2's worth. It's about 1/3 the speed of the Intel chip. Okay, we'll move on to the second test. This is AND. And once again, you can see approximately the same speed from both chips. So the Phenom is around about 1/3 the speed of the Intel when we turn all of the cores on. Okay, and the Phenom is finished. So that's almost identical to the previous result. We ended up with approximately 3 times the performance from the Intel chip. Let's move on. Okay, number 3. So this was a bit of an upset when we were doing single core. The Phenom was very good at shift reg CL. Very good at that instruction. And you can see here, even with all of the cores turned on, the Phenom is still, considerably better than the i7 at this particular instruction. Got to wonder why. Why is it so slow on the Intel chips? This instruction just, disastrous performance on Intel chips. Okay, so the Phenom has finished. It finished and it executed approximately 30 billion instructions per second when it was performing that little shift instruction. The Intel chip's going to be going for a little while, but it's a lot faster than it was. Yeah, so with 1 core going, the Intel chip was taking almost 1 minute to perform 100 billion of these shifts. Now, with 12 cores going, it's considerably faster, but, the performance is still pretty... it's not great. It's really not great. Intel, what are you doing? Yeah, there you go. So the Intel has now finished. It was less than half the speed. Less than half the speed. Let's just have a bit of a pause. So it ended up executing 14.75 billion of these shift instructions per second versus the 11-year-old Phenom's 30 billion instructions. Interesting stuff. Let's move on to the next. So the next test is MMX. So Intel has been open about purposely slowing down MMX. Let's see how it goes. Okay, so with all 12 cores going, the Intel chip is actually not terrible at MMX. Yeah, it's slightly faster than the Phenom. So with MMX, we ended up performing 82.5 billion instructions with our Phenom in 1 second, and 85.3, just about, billion instructions with our i7. I would be interested to see how modern Ryzen chips deal with these MMX instructions. I don't know if AMD has added the little performance hit there that Intel has added, or if they're perfectly happy for coders to keep using MMX. Okay, but let's move on. So the next instruction to test is CMOV, CC. CMOV, test it faster. What's happened? It broke. Okay, here we go. This is CMOV. Okay, the Intel chip is off and flying. We've got 3.57 seconds versus about 2.4. Slightly faster, I'd say. Yeah, slightly faster. Well, there you go. It ended up performing at about 1.485 Phenom 2's worths. Nice one, Intel. And what's the Phenom going to score? I wonder. It's going to score 1 Phenom 2's worth. Okay, so we ended up there with a score of 30.1 billion instructions per second from the Phenom and 44.68 billion instructions from the Intel. And the final operation that we have to test is flops, or floating point operations per second. Let's do it. And they're off and racing. It's hardly a race here, people. Look at that. Okay, so the performance in flops of the i7 8750 is it's fast. It's very, very fast. Absolutely annihilated the 11-year-old Phenom, which kind of makes sense in a way. And it's done. So we'll just hit a bit of a pause there. We'll have a look at these results. So the Phenom ended up doing 41.36 billion floating point operations per second, and the Intel i7 ended up doing 315.8 billion floating point instructions per second. So the floating point performance on this Intel chip is really, really good. Really good. Yeah, 7.633 times faster than this 11-year-old hardware. Makes sense. I mean, it makes a lot of sense, really. Okay, so what we might do is just have a quick look at a bit of the code, just so that we get a bit of an idea of exactly how this thing works. And so if we have a look at the benchmarks themselves, so we'll go over here to add reg 1. It's all awesome. And this is the code just here. So it's unrolled 8 times. So instead of just performing add RAX1 100 billion times, we actually unroll it 8 times and use different registers. I haven't bothered to sum up the total or anything and return it or anything like that. We're only interested in performance here. How long does it take? So I've unrolled the instructions so that it takes 8 registers, RAX, RDX, all the way down to R10. And then I've unrolled that, 16 times. Yeah, so really, really heavily unrolled. And this code approaches the theoretical maximum speed that this hardware can actually perform these instructions. I'd say, it's just a guess from memory, I think it's about 90% of the theoretical maximum. Is modern hardware getting faster? I think the only real answer that we can say, I think it's safe to say that generally speaking it is. I mean, my CPU here is it's not really modern, it's a couple of years old and it's a laptop. Old hardware used to be able to do some pretty good things too. So this old Phenom 2 was really good at shifting. It's good at MMX. It's really good at 3D now. Not that it matters. Modern hardware is becoming really good at parallel. So it's getting more cores and it's also getting better at sim deprogramming. Yeah, by and large, you'd have to say that the Intel's performance in flops is really where the performance is heading. That's really what hardware does really well. That's why modern hardware feels so much faster than old hardware. But outright, is it faster? You can't say. Yeah, the Phenom, the old Phenom 2 could do some marvelous things. And it was a beautiful chip, really. Beautiful chip. I started this channel with a Phenom 2, 810. Good times. Good times. Anyway, I've got a Patreon. You can head over there and say hello, or you can go over to Facebook and say hello. I'd really like for people to go over to the GitHub. All of these links are in the video description, so you can go over to the GitHub and run this program on your hardware and find out today how many Phenom 2s is your CPU. And if I get this video up before New Year's, have a good New Year's. Yeah. I'm looking forward to 2020. We're in the 20s again. The roaring 20s. Cool. Other than that, just want to say thank you very much for watching, and make sure you have a really good day.